All right, so the second conic section that we're going to look at are ellipses, or an ellipse. People like to call them ovals. So this is a ellipse, or this is an ellipse. The way they're defined are, you imagine I've got two foci, and let's say I've got a string here. Do you see my string?
Yes.
There it is. I looked for a string, couldn't find one, and Aiden wasn't willing to cut his earbuds. That's what they're called. All right, or shoelace is probably too long. So imagine that you've got a string here, and I put my finger in and I pull it tight. You can imagine that it would be like tight, kind of like that, and I put a dot. And then I put my finger in the string and I pull it tight right over here. There's another dot, and I put my finger in the string and I pull it tight, and it's right over here. Pull it tight, it's right here. Then I put my string on the other side, pull it tight, and all of these points made by taking the string and pulling it tight, where it's anchored at two spots, will all form these points, which is called an ellipse. It's an ugly ellipse. But if you take a string and you go just wrap it around like this, and if there's a pencil in it, you can draw an ellipse. So the definition of ellipse is all points that are equidistant, or not equidistant, that this distance plus this distance, I'll call it D1 and D2. And in the first one, D1 and D2. The D1s and D2s are always add up to be the same thing. Okay, so on my little sketch in the notes, there's a D1, there's a D2. All points created from that. So these two things in the middle are called foci. That's a focus, that's a focus, so those are both foci. So there's two focuses called foci. Alright, so more about an ellipse. If you have a horizontal major axis, this is a major axis, just because it's the longer of the two axes. Or you could have this, where the major axis is vertical. Just remember, the major axis is the longer of the two, and then what do you suppose this is right here? If this one's the major axis, what's this one? Aiden!
The minor axis.
The minor axis. Good. So this is minor, and then this would be minor. All right, so more specific, this distance right here is A. It is half of the major axis. So if it's a vertical major axis, this would be A right here. This is B, which is half of the minor axis. And again, if we have a vertical major axis, B would be right here. This is the center. And then remember, it has two foci. Grab my different flavors here. We'll call this focus 1 and this focus 2. Those are the foci. Here's one and here's one. Those are the foci. And the distance from the center out to a focus, and that is C. So A is half of the major axis, B is half of the minor axis, and C is the distance from the center out to a focus. So this also would be C right here. So what's the biggest of those three, A, B, or C? This is important. What's the biggest, A, B, or C?
A.
Everyone sees that A is the biggest? Okay, so when we do our formula, we put the biggest on the side by itself, kind of like the hypotenuse of the Pythagorean theorem. Is this the Pythagorean theorem?
No.
Kind of looks like it, same letters, but it's not, because Pythagorean theorem is a squared plus b squared equals c squared. In this case, A is the biggest one. So a squared equals b squared plus c squared. That's how they're related. Oftentimes you'll have a and you'll have b and you have to find c, or you'll have a and c and you have to find b. All those are examples. All right, so there's two different formulas, one for a horizontal major and one for a vertical major. If you have a horizontal major, first of all, a you said is the biggest and it's half of the major axis. If a squared is below the x's being squared, that means it's going to be horizontal. If a squared is below the y being squared, that means it's more a in the y direction. It's going to be a vertical ellipse. H comma k is the center. Both x and y is being squared. We always add the two and it's always equal to 1. Okay, so these notes that I'm providing, these are going to be good for you to go back and use for resource. Like right now, this is just a lot of information. So a couple examples and then you can go back and revisit these notes. A squared equals b squared plus c squared. Okay, so first example. Let's say I have x squared over 25 plus y squared over 9 equals 1. And we'll find, let's find the center. Well, the center, it's not x minus anything or x plus something, so it's going to be 0, comma 0. We'll have to make a sketch for sure. So and unlike parabolas where it was just kind of rough sketch, your sketches are going to have to be specific for ellipses. So I'm going to suggest, actually kind of demand that you use graph paper when you're doing these, because I'm looking to make sure that they go through the correct points. Okay, so our center is at 0, 0. What else do we know? A is always bigger than B. It's either a squared on the first one and b squared, or it's b squared and then a squared. Can anybody tell me what a is in this problem? Dolson. Sorry.
25.
No, that's what a squared is. Elena.
5.
It is 5. Very good. Because that's a squared. So a in this problem is 5. Can somebody tell me what a represents?
Half of major.
Very good. Half of the major axis. Okay? Also, the a squared is below the x being squared. So that means it's a horizontal ellipse. Okay? So if this is my center, this is the one end of the major axis, and this is the other end of the major axis, because this distance is a. What's b in this problem? Dolson.
3.
3. Very good. So b is 3. How do I know that? Because that's b squared right there. I know that this is a squared because it's bigger than 9. So that's a squared, so a is 5, then b must be 3. And b is the half of the minor axis, 1, 2, 3, 1, 2, 3. So when you're making a sketch, your ellipse, as ugly as you want to make it, has to go through those points. Okay? Make sure it goes through here, 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 and back to there. That's not a terrible one. Okay? Sometimes they turn into diamonds or all these different. Make sure you go through those points. Another characteristic of the ellipse that I have not told you is vertices. This is a vertex, and this is a vertex. So my one vertex is at 5, 0, and my other one is at negative 5, 0. So vertices are just the ends of the major axis. Okay, all significant points lie on the major axis. You've got the center, you've got a couple foci, and you've got the vertices. Everything is on the major axis. So how do I find C? If I want to know what my foci are, how can I find C? What do you think, Ashley?
Half of 5.
It's not always going to be half, though. It's not halfway. It looked like it in the drawing, but we have an equation.
Oh.
How do I find C? Yeah, Lena.
Can you do 25 minus 9, and then whatever the result is, square root?
Very good, because the equation is a squared equals b squared plus c squared. A is the biggest of the three. So now we have a squared, which is 25. We have b squared, which is 9, and we can find c by using that equation. So then subtract, we get 16 equals c squared, and this turns out to be a nice number 4. They aren't all going to be. There's a lot of times you'll have square roots, but in this case we get 4. So my foci, if c is 4, 1, 2, 3, 4, there's 1. 1, 2, 3, 4, there's 1. So the foci would be negative 4, 0, and 4, 0. Okay. There's one other, I keep saying one other thing. There's something called eccentricity. Eccentricity is how round it is. Eccentricity is always C over A. It's a measurement of how round the ellipse is. So in this case, if I wanted to find the eccentricity, the C is 4 and the A is 5. So our eccentricity is 4/5. How could it be where your eccentricity would be 0? What would we need for the eccentricity to be 0?
Circle and negative.
Would it be a circle? Look at the equation. What would have to be 0 in order for, yeah.
C.
What would have to be 0 is C would have to be 0, right? If C is 0, I get an eccentricity of 0. And if C is 0, that's the distance from the center out to a focus. If my distance from the center to a focus is 0, then what kind of shape do we have? A circle, like you said. You were right. Okay, so if these two came completely into focus right here, where the C is 0, then we have 0 for eccentricity, which makes it a perfect circle. All right, so another example. Let's try, I better make one up that, I was going to do completing the square right now. We better start with another easier one. How about x plus 2 squared? Get as far as you can with this. I'm not going to give you that much time just because I would not expect you to get that far with it, but I want you to give it a shot. So give it a little bit of time. See if you can come up with the center. We're going to have to do a sketch. Eventually we have to find the foci, the eccentricity, the vertices. So those are all things we'll be able to find. Go ahead. I'll give you a minute or two. All right, so we're going to start with the fact that we have a center of negative 2, 3. Negative 2, 3. And what else do we know here? Yeah, Aiden.
It's vertical.
Good, it has a vertical major axis. It's a vertical ellipse, and you know that because, why?
Because the A is underneath the Y.
Very good. The bigger number is underneath the y. And can you tell me what A is, Dolson?
4.
A is 4. Very good. It's always the square root of this or the square root of this. A is always bigger, so we're going to say A is 4, which makes B what?
1.
1. Good. All right, so it's time to maybe start the sketch here. So if I have negative 2, 3, there's my center. And A is 4, and it's vertical. 1, 2, 3, 4. There's the top. 1, 2, 3, 4. There's the bottom of my ellipse. We know B is 1. Oh boy. It's a skinny one. All right, there's my sketch. Foci, so I need to find out what C is. So we know for all ellipses, a squared equals b squared plus c squared. So a squared is 16 equals 1 plus c squared. So c squared equals 15. So c is the square root of 15.
It's like 3.87.
All right, so 3.87, thank you. So if I wanted the exact, it's somewhere like right up here and somewhere down here. The exact value for those foci, I would say, is -2, comma. And to get to here, I have to go from my center, which is at 3, and I have to add square root of 15. That's the square root of 15 right there. So it'd be 3 plus the square root of 15. That would be the exact answer. I would. Oh, would I accept that? Is that what you're asking me? I would accept that, yeah. But for me, I like to be exact. I'm going to go from the center down square root of 15, so it'd be -2, 3 minus the square root of 15. Those are my two foci. Eccentricity is just C over A, so square root of 15 over 4. And the vertices, we already have them sketched right here. What's that? -2, is that 7? -2, comma, -1. How many got pretty far on that whole process? That's good, after one example. And I gave you a difficult one. I gave you square roots for the foci. I gave you a center that wasn't at 0, 0. So, time to challenge you a little bit with some algebra.
No.
How do I know this is not a parabola? Good. You have x being squared and y being squared, so I know it's not a parabola. It could be a hyperbola, which we have not talked about, but seeing that we're doing a lesson on ellipses, I'm guessing it's going to be an ellipse. So we have to isolate the x's, so I've got a 9x squared plus 54x plus something, eventually, or I'll just put it plus 4y squared minus 8y, and I'm going to get rid of that 59 by moving it over. So we have to complete the square not once, but twice. So we talked about this yesterday. If you have a coefficient of 9, you have to pull it out right away. And if you have 4 there, it'll be 4 parentheses y squared minus 2y plus something equals 59. I'll see if you can try completing the square here. I'll give you a second to catch up. All right, so what number goes right here? What goes right here? 9, because half of 6 is 3, that's 9. So I have to add how much to the other side?
9.
Try again. 81.
Oh, 9 times 9 is 5.
Yep, because it's 9 times 9. We just added 81 to this side. And what goes here, Ethan?
1.
1, so I have to add how much to the right side? Anybody? 4. All right, so 9 parentheses x plus 3 squared plus 4 parentheses y minus 1 squared equals 130, 144. So all of our examples, what is always on the right side? What do we always have over here?
A number?
Look at all the examples we just did. What's it always equal to?
1.
It's always equal to 1. We have to have 1 on the right side. Okay? So in order to get 1, we have to divide by 144. Divide by 144 and divide by 144. So now 9 over 144 goes in there, what, 16 times? X plus 3 squared over 16 plus y minus 1 squared over 4 goes in there 36 times equals 1. So after all of that, we have a workable equation, just like we had before. So why don't I just narrow it and say find the foci. One question, so we don't have to spend as much time on it. Find the foci of that ellipse. I'll give you a minute. Check your answer with somebody next to you. See if you got the same thing.
Without our permission?
Yeah, we got it.
All right, so what's my A here?
36.
Wrong. What's my A here?
6.
C. What's my B?
4.
Vertical or horizontal?
Vertical.
It's a
Vertical.
vertical because the bigger is below the y. So my center is -3, 1. It's like you have to do all this stuff to figure out the foci. So -3, 1. It's right here.
Really?
A is 6, so it's right up here. B, or looks kind of like this. All right.
Doing too much.
It says -3, +1.
Yeah, that's what I have. I don't know what you're talking about. -3, +1.
That's two.
Positive 2.
No, I'm going up by 2. Am I seriously recording this? Like I said, -3, 1.
There we go.
Thank you.
That looks right.
So we said A is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. B is 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so there's what my sketch is supposed to look like. All I wanted was the foci. So I know they start from the center and we go out C units in each direction. So to find C, A squared equals B squared plus C squared. 36 equals 16 plus C squared. So C squared is 20. So C is the square root of 20. All right, so my foci, I know that I'm going up from there. So it's going to be -3, comma 1 plus the square root of 20. And then -3, comma 1 minus the square root of 20. Those are, and I don't know what the decimal is. Yeah, those.
Can't you just take, like, if it's gonna be vertical, can't you just take the X, put it in front, and then put the foci that you did in the back instead of wrapping it?
Yeah, so his question is, do you have to make a sketch, is basically what you're saying.
Because I can figure it out without the sketch.
So, is there a reason to do the sketch?
It looks cool.
It looks cool, there's a good reason. Any other reasons? So you don't screw up. Like if you're trying to figure out the y, and like, do I add it to the x or to the y? Is it a vertical? Make a sketch and make your life easier by just saying, well, it's clearly just going to go up a C and down a C from the center. But if you can do it without a sketch, go ahead.
All right.
All right, last problem.
Is it going to be horizontal this time?
0, -1. No, it's another vertical.
Oh my God.
Should I change it? Should I make it horizontal?
Yes.
Does it feel prejudiced against all the verticals? Okay. So let's make a major axis. Let's say 5, 0, and -1, 0. All right, do some stuff with this one. Meaning, we're gonna have to do a sketch. I want you to find the vertices. I want the foci. We don't have to find the, I guess we better find the center because that's not even given to us.
Is the 5 and the -1?
We don't need to find,
Where the foci are, right?
we don't need to find eccentricity. Yeah, question?
How do we find the vertices again?
Start by making what you can out of a sketch. And then you can maybe find A and B and C stuff from the sketch. Good question. Yeah.
Is the 5 and the -1 where the foci are at?
Those are the foci, yeah.
Alright.
So you might not have much trouble finding the foci, seeing that they're given to you. All right, so we have a major axis at 8. We've got foci at 5, 0, and -1, 0. 1, 2, 3, 4, 5, -1, 0. So those are the foci, which puts our center where? Right in the middle, which is 2, 0. Okay. So what else do we know?
The vertices.
We know the vertices? Yep. Elena.
We know that the major axis is 8.
Good. Major axis is 8. From the center, we can go out 4 in each direction, right?
Yeah.
1, 2, 3, 4.
6, 0.
So, can you tell me what A is?
4.
4.
A is 4, half of the major axis. If A is 4, what's B? Do we know yet?
Figure it out.
How can I figure it out?
A squared plus B squared.
Well, we need C. Do we know C?
Yes.
Yeah.
What's C?
3.
C is 3. Very good, because it's the distance from the center to a focus. So C equals 3. So then A squared equals B squared plus C squared. 16 equals B squared plus 9. So B squared equals 7. So B is the square root of 7. All right, so foci, those are already given to us. We kind of got a sketch. B square root of 7. Now I'm going to have to do a decimal. It's bigger than 2 and less than 9, or less than 3. So between 2 and 3, between 2 and 3, we'll call that pretty good.
You feel the vertices.
And then the vertices are 1, 2, 3, 4, 5, 6, 0, and -2, 0. If I wanted to do eccentricity, it'd be just C over A. Questions? Yeah.
Could you write out the equation by any chance?
Yeah. Let's do the equation. What? I'll give you a second to try it. See if you can come up with an equation. Thank you. That was a good idea. Okay, so we need the center for the equation. The center we already know is 2, 0. So it's going to be x minus 2 squared, and it's going to be y minus 0 squared. And it's always equal to 1. So now we just have to have a and b squared. So a squared is 16. Do I put that below the x being squared or the y?
X.
X, because it's a horizontal. So that's 16, and b squared is 7. How many got that for an equation? Very good. So right now it seems like you understand ellipses. Do some practice with your assignment. We'll spend another day on it tomorrow. Good job today.